The future of CAN in mobile machine applications. We will look into road vehicles and body application units. We will look to mobile agriculture machines, mobile construction machines, special purpose mobile machines. And then I will introduce something what is called the common parameter sets, how we could improve the standardization. It was already mentioned by Thilo that we have 3 different protocol types in the moment specified internationally. This is CAN CC or CAN Classic, using 1 bit rate up to 1 megabit and data field lengths of up to 8 byte. We use CAN FD with 2 bit rates up to 667 kilobit in the arbitration phase, and in the data phase up to 8 megabits per second, and we have a data field length of up to 64 byte if we're using so-called CiC transceivers. For CAN XL, we have also 2 bit rates, same arbitration bit rate as in CAN FD, the limitations, and we can go up to 20 megabit per second if we're using the CAN CiC XL transceiver chips, and we have a data field length of up to 2048 byte. We also have then 4 different options for the physical media attachment, or that's what you would like to call the transceiver chips. We have the CAN high-speed transceiver chips enabling bit rates up to 1 megabit. For CAN FD, we can go up to 5 megabit, but only for point-to-point communications. CAN SIG transceiver allows at bit rates in the data phase of up to 8 megabit per second. And CAN SIG XL even allows us to have a bit rates in the data phase of 20 megabit per second. This gives you a lot of different opportunities, and this means CAN is highly scalable for different applications. Most of the mobile applications are low-speed applications from the application point of view, because there is nothing what is moving very quickly. Just to give you an idea. In the moment, we are updating ISO 25200 in the ISO. So we add additional body application units like aerial working platforms according to EN 280, fire CAN, and hook loader units, nomadic forklift units, outrigger control units, refuse collecting units, and we have to update or to improve them because we have in the old version we have had just also a reference to old versions of the EN standard, and we turntable ladder units, underride protection units, water foam container, warning signal units, etc. So this means this is a lot of new parameters, and you will see that this will be very huge and powerful and mighty documents. If you, just as an example, using a firefighting body application, you can, because any of these units are virtual units, you could do them in the network is virtual as well. So we don't tell you what you have to use. It could be a J939 network with CAN FD support or not, we don't know. And the documents are written in a way that they can be adapted or mapped to different communication technologies. If you do so, you might run out of bandwidth. But this is not really true if you look to CAN XL, because CAN XL has enough bandwidth for all these subnetworks, and you can run them virtually physically on one single wire. This would be then the next approach, that we integrate and map them to CAN XL. But this is future, and then we don't have a lot of subnetworks. We can run all of them virtually on one physical layer. One physical network. We also need some more for energy management, as Rainer has already introduced, but this is not sufficient. We need a so-called managing unit for that. And this is a cascaded approach that you have in the vehicle already some energy available. If you think about e-trucks or e-vehicles, and then you have for the body application battery by themselves, and you can share the different batteries, but then you need a management unit for the electrification. And this is something what is not yet standardized. So we have a lot of different applications running there with different battery management system, and Rainer has shown that there are several of them, but we need to harmonize them and to provide a so-called power management unit, which is capable to run even cascaded energy management supplies. In the agriculture industry, we have also the need to extended standardized interfaces for fleet management and for telematic gateway units. It's not yet existing, but for bigger farms, we would need this as well. And also for the suppliers, they want to make preemptive maintenance of their devices and all the things. This should be done by means of standardized interfaces. And there's also no CAN-based electric power management system standardized. So also this is something what is an open issue and needs to be done in the next years. And we also have no standardized embedded networks for dedicated implements, for example, for a potato harvester or for a sprayer or something like that. This would simplify implement designs, as well as you increase the possibility to buy off-the-shelf products for different applications. And so that you have, because of an increased number of devices, a lower price available on the market. And there is also no high degree of standardizing mobile agriculture robots. This is also something what needs to be improved. And we see that in the future, there will be more and more so to say, automated guided vehicles on the fields and in other applications, including vineyards or other applications. But all this is known, but those industries are slow in adapting this. Needs some time. The mobile construction machines that we have heard this several times in this session today, that the MIG 4.0 bus by VDMA. This is a starting point for standardizing a mobile machine integration network for mobile construction machines. The MIG bus specification is available for comments by July 2025, and Dagmar has already given the correct date. CiA collects and evaluates comments, so please submit your comments to CiA. And then we will discuss them end of May, and we will invite you to discuss them. Then we will harmonize them and submit them to VDMA. There is some issues regarding the physical layer. There are some issues regarding the use of proprietary parameter group numbers and also the functional safety, how this is used and implemented. For more complex attachments, there might be also a need for embedded networks, because they would simplify attachment designs if they are highly complex. Standardized functional safe embedded networks for aerial working platform is another topic. They could be applied to different mobile machines, for example, firefighting vehicles, or for truck-mounted cranes, or even for some other applications. Special purpose mobile machines, there are provided many different special purpose machines, including snow gromers, aircraft de-icing equipment, underground surface drill rigs, mobile 3D concrete printers, etc. This is endless. Some of them do not follow any standardized mobile machine integration approach, as we know it from the ISO bus from ISO 25200 or MIG 4.0. They need to adapt the one or the other standard. At the end, I would like to have all them that they use the same integration network, but this will be on the long term. AGVs and AMRs provide a vehicle and a machine part, so they are quite similar to that what we have seen in the mobile machinery, and some of them they have so many similarities that they are just small machines on wheels, or they are bigger machines. If you're looking to some in the harbor, some automated cranes, etc. So unfortunately, there is no common standard available in the moment. So we also work on this in different ISO standards to harmonize all the things. And there is no high degree of standardizing mobile agriculture robots. This is something what is also on the to-do list for the next generations. What would be very helpful would be if we would have a common parameter sets. In order to avoid double specification, it would be helpful to specify generic and specific parameter sets for in-vehicle network applications, mobile machine integration network applications, and in-machine network applications, independent of the used communication technology. Then we could map them to different technologies like CAN-open, like J9039, or any other higher layer protocol which will be standardized in the future. We have some proposals how to do this. The isobus, they have a data dictionary. J939 has a data dictionary. This would be easy if they would be written in a better way. Then we can really easily use them with some tools to generate software of that. But today, this is a nightmare because the formats are quite different, and there is no common description of those parameters. And this would be very helpful if we would have a parameter database and, so to say, parameter sets, which we can specify, and then can use the digital annexes to generate software more or less automatically. So this is something what is in the long term needed, and I hope we will achieve this in 10, 20 years about. Thank you. My last slide is standardization needs patience. And if you want to go fast, go alone. If you want like to go far, let's go together.